This video is the first in a series showing you how to use our first-party visualization software, the CrystalGrower Visualiser. The CrystalGrower Visualiser is a custom code written to be used with CrystalGrower and is coded in C++ and OpenGL using calls to the Windows API. It lets you visualize the results from your CrystalGrower simulations and manipulate them and produce images and movies to use in your presentations. It's intended to be used as a companion to Ovito, so Ovito can do some things that the Visualiser can't, but the CrystalGrower Visualiser can do some things that Ovito can't. For example, showing the natural tiles that make up framework structures. This video will cover the basics of using the CrystalGrower Visualiser, and then we'll progress on to making videos and using the Visualiser for high throughput processing. So the executable for the Visualiser is included with your CrystalGrower download. It's in this folder here. To run the CrystalGrower Visualiser, you simply double click the executable and it will open the user interface. So the first thing we need to do is load a structure into the Visualiser. So this is performed in two steps. We first need to load a data file, which has the extension .vis, V-I-S, which will construct the objects that the Visualiser is going to display. For example, the tiles or molecules that make up our crystal structure. So if I go to File, Open Data File, or I can press Ctrl O on my keyboard, I can then select anything with the extension .vis. So this is a series of simulations on a zeolite structure, AFI. So I'll just open this first one here, and it'll tell me that it's loaded 24 tiles. So these refer to the natural tiles that make up the structure. Then I need to load the actual coordinates. So the coordinates are going to be where these objects are placed in the scene. So I can either click File, Load Coordinates, or I can press Ctrl-Shift-O on my keyboard. It gives you a warning because these files can be quite large. And I'll just open one of these simulations that I've run already. So I'll go for this one here. It takes a short amount of time to load depending on the size of your simulation, and it'll tell you how many frames you've loaded from your simulation. So you can see we now have our structure displayed on the screen. You can observe the colouring we've used here. This is layer colouring, so this is specified when you run your simulation, but we can change this later. So now I'm just going to start rotating the structure with the mouse. So by default the mouse is in rotation mode, so if we go to mouse mode up here, you can see the modes that you can choose. So if I hold down the left mouse button, the crystal will rotate about the X and Y axes. And if I hold down the right mouse button, the crystal will rotate about the Z axis. If I change the mouse mode to scale mode, if I hold down the left mouse button and move the mouse, it will zoom the crystal in and out. And if I swap to translate mode and hold down the left mouse button, it will move the crystal around in the X and Y directions. If I hold the right mouse button, it'll go back to rotating the crystal about the Z axis. So now I'm going to move on to translating the structure, so moving it around the screen. You can either achieve this by switching to mouse mode translate, as I've just shown, or you can use the W, A, S and D buttons on the keyboard. So if I switch back to rotate mode, just move the crystal around a little bit. And if I now press A, it'll move the crystal to the left. If I press D, it'll move the crystal to the right. W moves it up, and S moves it down. If you want to zoom in and out, that's the Z key and the X key. And with all movement controls in the Visualiser, you can hold down the Shift key, which makes the movement smaller. So if I hold Shift and Z now, you can see the movement's a lot smaller. Or Shift and A moves the crystal a much smaller amount to the left. This also works for the mouse rotation, so if I hold Shift and left click in rotate mode, it moves the crystal a lot slower than if I didn't have Shift held down. If you hold Control and Shift, it'll make the movements larger. This only works for the translation keys, so Control Shift Z makes big jumps towards zooming into the crystal, Control Shift X, big jumps away from the crystal, Control Shift W and S moves the crystal up and down by quite a lot. If your simulation frame is quite large and you're displaying a lot of objects on the screen, it can sometimes affect how smooth these movements are. A good way to get improved performance when you're moving your structure around or making a lot of changes is to press Ctrl, Shift and P, which switches to points. So you can now move your crystal around a lot quicker, set up the location where you want to look without having to wait for it to load, and then switch back to tiles by pressing Ctrl-Shift-P again. You can also change this in the options here. If you ever want to reset back to your original viewpoint, you can press Ctrl-Shift and R, and that will reset you to the location where the visualizer originally opened your crystal structure. All of these controls are listed in the controls menu here. Now let's look at changing the color schemes and the display modes of the species in the visualizer. So if I go to drawing, depending on which structure type I've got loaded, different options will be made available. So if I go to tile crystals, that's what I'm showing right now, I can change from layer coloring to coloring by tile type. So this is AFI, it's got 4 tile types in it. So if I rotate the crystal to the side, you can see we've got a few different colors now, compared to if we switch back to layer coloring, which just colors the actual terraces. So we can also switch to block coloring, which just colors all the tiles the same. And we can also switch to spheres, so we can display all the same coloring that we had for tiles, but using spheres as the objects instead. So layered spheres. So now all the objects that are originally tiles are now spheres. We can also change the sizes of the spheres. Currently these tiles are sized by the root mean square average of the tile coordinates, so the sphere size will change based on the tile size. If we switch to average spheres, then everything will be averaged out and everything will be given the same size. So if we zoom in close to the surface, you can see all these spheres are now the same size. If I turn off that option, some are larger than others. If you want to change the sizes of the spheres, you can do that by pressing Ctrl+ or Ctrl- to increase or decrease the size of the spheres respectively. And we can also select the layers one at a time and change the colors that are being used to display them. So if I press space on the keyboard, it will start to cycle through the layers that are displayed. And it will show in the overlay down the bottom which layer is selected. I'll explain the overlay a little bit later in the video, but for now I'm just going to add a background so it's clear and you can see what it's saying. So if I keep pressing space, I can cycle through the layers. Let's say I choose layer number 4, and let's say I wanted to change the color of this layer. So I can either press Ctrl+C on the keyboard or go to coloring and choose change single color. So here I'm going to switch it to a really vibrant green color just to make it obvious. And then if I press Ctrl+Shift and space, I'll deselect everything. And you can see the colors changed. You can also keep pressing space and it'll cycle through all the 6 layers. An important thing to note is the first 4 layers are the layers that CrystalGrower has colored. Layer 5, normally shown in a pink color, is designed to show things that weren't identified as being part of a layer, but they are grown units. If I zoom in through the crystal, you'll be able to see some that have been selected. So these are some internal defects that are still present. And then if I press space again, I'll switch to layer 6. And layer 6 is meant to represent the defects that were removed when we ran a second sweep in CrystalGrower. We'll cover these in a bit more detail in the internal defects video. So if I press space again, it'll deselect everything and we're back to selecting nothing. So these options also translate to the tile drawing. So if we go to type tiles, I'll go through the same options here. If I press space, it'll show a certain tile type has been selected and it'll tell you which tile out of all the tile types that has been selected. We can recolor these tiles through the same mechanism. I'll press Ctrl+C here. I'll change it to a red color. And then I'll switch to the next tile type, change that one, so it'll set that one as blue. And then I'll switch to the third tile type, change that one to purple. And then the final tile type will set as green. You can see we've got a very different color scheme to what we started with. In addition to selecting tiles and recoloring them, you can turn tiles on and off. So if I want to turn off tile type 3, I can press space to scroll to it, and then I can press the F key, which is the toggle to switch a tile on or off. So now you can see that I've removed that tile from being displayed. This also works on layer coloring mode, but you'll be switching off layers, and in spheres mode. If you wanted to quickly turn all the tiles off, so you could just scroll through them one by pressing the spacebar, you can press Ctrl-Shift-G, and that will remove all the tiles. And now if I press space, it'll just display one tile at a time. And then we can use the F key to turn them on or off. Again, same as before. So if I want to make them all reappear, I can press Ctrl-Shift-F and it'll turn them all back on. This works for all the other display methods in the CrystalGrower Visualiser. If you're representing your objects as spheres, you do have additional control where you can change the sizes of the spheres individually by selecting them. So if I press space, select tile type 1, and press Ctrl+, you can see I'm now making that one tile bigger compared to the rest of them. Now I'm changing tile number 2. Then I can make tile number 3 small, and I'll leave tile number 4 the same. You can also improve the resolution of your spheres being displayed in the CrystalGrower Visualiser. So if I zoomed in quite close to the surface, you can see that some of these spheres are quite angular because I haven't used that many triangles to divide them. So if you were taking some close-up images, you'd probably want these to look a bit better. But it also takes a bit more computer power to render. So it's best to do this after you've manipulated your crystal to look how you want. So let's say I wanted to now increase the sphere resolution. I go to Drawing, change Sphere Resolution, and then I can use the same keys as for resizing the spheres to increase and decrease the sphere resolution. So Ctrl+, you can see now the spheres are looking a lot smoother and shinier. If I press it one more time, you can see the lighting gets even better. So this would be a good point to save an image. Maybe with some better colouring. I'll switch back to layer colouring, which will retain all the sphere sizes that we've set. So if I zoom back out, and I'll just take an image from here. So you can either do this by pressing File, Save Image, or you can press Ctrl-S on your keyboard. So you save images as bitmaps from the visualizer, so I'll just call this one Test. And if I go to my simulations folder, I'll now have my bitmap saved that I can open and use in presentations. Now I've made quite a lot of changes to this simulation since opening it. So I don't really want to have to do all those translations and rotations again and all the recolouring steps. So there's a state saving function incorporated into the visualizer. So provided you have the simulation loaded that you performed those operations on, or a simulation of the same crystal structure, because state files can be used as long as the .viz file is the same between two simulations. I first need to save this as a simulation state. So if I go to File, Save Current State, and I can choose the location here. So I'll call this one Tutorial Save. And state files are given the extension .stat. So now if I restored my simulation back to its original state, I can say reset all parameters, gives you a warning, and this is exactly how our simulation was opened. I can now press File, Load State, choose to load a simulation state, and I'll load my tutorial save state. You can see it's taken us right back to where we were to start with, resized everything, set all the resolution as we had it. So this is particularly useful when you're making movies, which we'll discuss in the next video. If you only want to save the colouring that you've used, you don't want to save the translation and rotations and so on, you can do that by just pressing File, Save Colour File. So these are given the extension .col, so I'll call this Tutorial Color. And we'll reset our simulation again. But this time we'll just load the color file. And that's done through coloring, change all colors, and we can choose our .col file that we just made. So you can see it's left everything else the same. We're still in the same drawing mode, we've just got different coloring. So you might also want to change your lighting. So if we go to the lighting tab here, we've got two options for lighting. Standard is based off of VMD's lighting, which is another visualization package. So you have 4 lights and a lighting correction with checkboxes showing you which ones are turned on and off. And then we've also got a lighting scheme from 3DT. So that's another visualization package covered in a later video where the lights are set up slightly differently. But you can choose which one you prefer. By default, it uses the standard lighting and has light 0 and 1 enabled and light correction turned on. Light correction is just a weak light coming from behind the camera just to correct for some shadows that sometimes are displayed incorrectly depending on what angle you're looking at your crystal structure. So if we turn off light 0, you can see it's gone quite dark, and I'll turn off light 1. You can see it's almost completely dark. If I finally turn off light correction, you can see the whole crystal is completely pitch black. So let's try turning on some different lights. Let's have 1, 2, and 3 turned on instead. We'll turn our lighting correction back on as well. So you can see that's a lot brighter than what we had before, so it might be a bit too much. It can be particularly difficult for tiles to get the lighting correct because their surfaces are sometimes perfectly flat, so they can reflect a lot of light. Displaying the structure as spheres generally gives you better lighting from long distances. So if we swap to layer spheres, you can see that that's reflecting quite a bit too much light there. We'll turn off light 3 and light 2. We'll go back to our original lighting. You can see it's a lot better. And when you improve the resolution, you get an even better lighting effect. So we'll do that now. You can see there's a lot more definition as I improve the sphere resolution. So if I move over to this view options here, there's a lot of options related to the overlay. So here we can show how the axes are displayed. So currently I'm showing XYZ axes, so just an orthogonal coordinate system. I can switch to ABC. So these are defined by my crystal's coordinate system. So I'm looking at AFI currently, which is a hexagonal crystal. You can see that's now gone to a hexagonal coordinate system. The angle between A, which is in red, and B, which is in green, is now 120 degrees, as you'd expect in a hexagonal crystal system. You can also turn off the axes by clicking the button again. So that just removes them completely. And you can also scale them based on your unit cell. So depending on your unit cell parameters, your A, B, and C lengths, you can resize your axes. So in this example, the C direction is much smaller than the A and B directions. So you can see that that arrow is shrunk. Then we also have the options related to the text overlay. So currently it's set to display the overlay. You can just click this to turn it off. You can just turn it back on. You can also display a full overlay. So that adds some extra information, tells you the coordinates on the screen, and it tells you the front and back buffer positions for when you're trying to cut off certain parts of your crystal, which I'll cover when I'm talking about net crystals at the end of this video. And you can also add a background to your overlay, as I showed earlier in the video, so you can see it clearly when you're looking over your crystal structure. So now if I press space, you can see it's selecting all the crystal layers, and it stands out a bit clearer when you're zoomed in on your crystal structure. You can also change the color of the text overlay, so I'll change it to just some strange color. I'll change it to orange. But this information can sometimes be useful, but you probably don't want it when you're taking images, so just remember to turn it off when you don't need it. The final option in the view window that I'm going to talk about here is this enable quaterni on rotation. So this is a different rotation system. If you turn it on, the mouse behavior will be slightly different, as it's using different calculations to calculate the rotations. But it generally works the same way as the default rotation. So I would only switch to it if you're having problems with the rotation. So if we reset back to our original view, I'll just quickly explain this reset option here as well. You can reset your view. When you say reset rotation, that sets everything to 0, 0, 0. So if we were rotated over here. So if I click reset view and click reset rotation, you'll see it sets everything back to 0, 0, 0. And if I do the same for reset translation, it sets translation to 0, 0, 0 as well. Reset sphere and bond scaling will just resize everything back to the defaults, and we've already seen reset all parameters. It just sets it back to the original viewpoint and sets all the parameters that you had back to the starting values. The help menu has a few options here as well. I've shown the controls menu. Manual is a link to our website explaining the visualizer, so there'll be a manual page up there explaining some of this in text form. About gives you some information about the software, and then Site CrystalGrower takes you to our home page of our website, where you have the citations for CrystalGrower if you want to use it in your research. So all the features I've covered thus far in the video are shared between both tile and net crystal structures. But I'm just going to open up a net crystal structure to show some extra options that you get when you've partitioned your structure as a simplified net. So the loading process is still the same. You open your data file first. So I'll choose calcite and one of the simulations I've run previously. You can see the information that comes up is slightly different. So it's loaded 5 molecules and 1 bond type. And then we'll load our coordinates again. I'll have to navigate to calcite again. And I'll open this XYZ file. You can see it's loaded quite quickly. As this is a relatively small simulation, it isn't perfectly colored either, but it's just for an example. So you can see I've got layer coloring again. I can scroll through and select the layers. I can turn them on and off and recolor them. Same as I could for the tile systems. But now if we go to drawing, we can now access all the options under molecular/ionic crystals. So the tile options are now disabled, but these options are all available. So we can have the usual type spheres, so that's defined by molecule type. So one will be calcium, one will be carbonate, and then we've also got a growth modifier added in here. So that'll be the third molecule type. The extra thing that you can access when you're using net-based crystals are the molecule drawing routines. So if I switch to atom type molecules, you can see it's now displaying the actual molecules that make up calcite. So you've got your carbonate ions and you've got your calcium ions. And then you've got your growth modifiers here as well, displayed as these grey spheres. Now we can use the selection routines that we showed for tile-based structures and species types, but apply them to atoms. So if I now press space, I'll just turn on the overlay background so you can see that again. If I press space, you can see that carbon is selected, oxygen now selected, and calcium now selected. So if I switch back to changing sphere size, I can shrink or enlarge these calcium ions specifically, and I can recolor them. So I'll change these to green, and then deselect everything. You can see these are now green. If I resize my spheres, without selecting anything, it'll resize everything at the same time. And I can also turn specific atoms on and off. So if I wanted to switch off all the oxygens, I could select oxygen and press F, and it'll turn the oxygens off. And I can use the shortcuts from before, the Control-Shift-G and Control-Shift-F, to turn everything on and off quickly. Let's say, for example, I wanted to change the bond coloring. So if I zoom in very close, and if I now hold Shift and press space, it'll select the bonds. So you can see these bonds are now displayed in a dull white color to differentiate them from the black bonds that were normally being used. And down the bottom you can see bond type 1 of 1 is selected. So now we can change the color of these too. So let's change this to some other color. Let's make these red. If I deselect, you can see these bonds are now red. You can turn them on and off as well with the same keys that you normally would use, but this time you need to hold Shift while you press F. So Shift F, and if I deselect, you can see the bonds are now all turned off. Just turn them all back on. Now the final thing I'm going to show are the depth buffers. So previously this information appeared when I showed the full overlay, which says the front and back buffer positions. So that's your depth buffers, which decide when things get cut off from view. The back buffer will be the far distance, and the front buffer will be the close distance. So if I zoom in a little bit closer, you can see it's starting to cut off the front of the crystal. Now if I want to reduce that, I can press Ctrl-Shift-N, and that brings the buffer closer to me, so you can see that number has now gone down to 7. Or I can press Ctrl-Shift-M, and it'll push it further back, so it'll cut off more of the crystal. We can do the same for the back face. So frequently when you're looking at atoms and molecules, the back face of the crystal might make it more difficult to see the front face of the crystal which you're investigating. So the back buffer is controlled by Ctrl-Shift-J and K. So if we do Ctrl-Shift-J, you can see that number's reducing. and it's now starting to actually cut through the back of the crystal. And it makes it a lot clearer, the front face that we're looking at. And if we want to just return to the defaults, we can just reset all parameters. And it'll return us back to our original system. If we turn on our full overlay, you can see the depth buffers have returned to their original locations. So that's a detailed overview of all the functionality of the Visualiser for generally visualizing structures. In the next video, I'll cover specifically how you make movies with the Visualiser and load some simulations with multiple frames.